Before we can study the factors which affect resistance, we need to understand some terms and concepts which we're going to use in those investigations. A resistor is a component which has resistance. Resistance means how difficult a component makes it for electric current to flow through it. The symbol of resistance is R and the unit is ohms. Current strength refers to the rate at which electric current flows. Put very simply and a little bit wrong, it's how quickly the electrons move around the circuit. It's actually not how quickly, it's how many groups of them pass a point every second. But it might be easier in the beginning to think of it as related to how quickly the charges are moving around. The symbol of current strength is I and the unit amperes or milliamperes. We shorten amperes to A and milliamperes to small m and capital A. We measure current strength with an ammeter, which must always be connected in series. If you connect an ammeter in parallel, you will fuse the ammeter, and that will stop the ammeter from working until you replace the fuse by opening the box and finding the fuse and pulling it out, and then putting a new one in. So it's really important to make sure that you do connect an ammeter in series so that you can avoid all that trouble of replacing the fuse. How will you know that an ammeter is in series? It must fill a gap. So before you connect the ammeter, there must be a gap in the circuit, and the ammeter closes the gap. Then you know that it is in series. We can liken electric current to different things to help us understand it. For example, we can think of the charges that move around the circuit like marbles that move around this marble circuit. We have a groove in which the marbles sit, and we push the marbles and then they move around. We are like the battery. We push the marbles, just as the battery pushes the charges that are in the wires. The marbles are like the charges. When they are pushed by us, then they move around. Just as the charges, when they're pushed by the battery, they move around. A resistor is like a piece of sandpaper under some of the marbles. The sandpaper makes it more difficult for the marbles to move over it, just as the resistor makes it more difficult for the charges to move through it. Just as a resistor has resistance, a sandpaper has roughness. The rougher the sandpaper, the more difficult it is for the marbles to move over it, and so there's more friction and the marbles slow down. The more resistant a resistor, the more difficult it is for the charges to flow through it, and so the current strength is slower. We can also liken this electric circuit to this water circuit. Well, this is actually not a water circuit, it's just a part of a water circuit. Circuit comes from the word circle. It must be a complete path, and this is just part of it. So you must imagine the rest of it. Here we have pressure exerted by a pump. The pump is not shown in the picture. And that makes the water move through the pipes, just as the battery pushes the charges through the wires. These big pipes are like good conductors. It is easy for the water to flow through them, just like it's easy for the charges to flow through the good conductors. This narrow pipe is like a resistor. It's more difficult for the water to flow through the narrow pipe, just as it's more difficult for the charges to flow through the resistor. The rate at which the water flows is like current strength I. How thick the pipe is related to resistance R. How hard the pump pushes is related to the voltage supplied by the battery. Often in an investigation, you use an indicator of a variable. What do we mean by an indicator? Here are some examples of indicators. They are all things which show us something about what we're really interested in. So the first one is a speedometer. It indicates to us how fast we're going. By seeing how far the needle has been rotated clockwise, we can deduce how fast we are going. And the people who made the car, they even calibrated it for us so that we don't have to do it by eye. We can actually look against the numbers and from that see how fast we are going. We call these lights that flicker to show where we are going to turn indicators as well. Why? Because they show which way we're going to turn. And that is what indicators do. They show us something else. In chemistry, we use indicators to show us pH. We get various kinds of indicators: bromothymol blue, universal indicator, litmus paper, and with many of them, a blue color tells us that the substance inside there is basic, and the red color tells us it's acidic. The color needs to be interpreted as telling us something else. The color in itself is not important, but what it indicates is important. Whether it's blue or red is not really important, but the fact that from that we can deduce it's basic or acidic, that is of value. Now, in the investigations we are going to do about resistance, we want to see how various factors affect resistance, but we're not going to measure resistance directly. We're going to use two indicators to tell us about resistance. These are the circuits we're going to use in one of the investigations. You can see that in each circuit we have a resistor, and we need something to indicate to us how resistant that resistor is. So what do we have in the circuits that are going to do that for us? Notice that each circuit has a bulb. Why is it there? And each circuit has an ammeter. Why is it there? The two indicators we are going to use to tell us about resistance are bulb brightness and current strength. The reason why the bulbs are there is that we're going to compare their brightnesses and from that deduce which circuit has more or less resistance. The current strength is going to be measured using the ammeters. The reason we have those ammeters in the circuit is because we're going to compare the ammeter readings for these different circuits, and by looking at them, we're going to deduce, this circuit has a higher resistance than that one. So how are we going to deduce that? Answer these questions to help you to think about it. What does a brighter bulb indicate to you? Does it show you that the wire's resistance is less or more? So here we have a bulb together with a resistor. Now in this case, the resistor doesn't look like a wire. We would just call it a resistor. But in our investigations that we're going to do, the resistors are going to be wires. You will see that clearly. If you were to see that this bulb was very bright, what would that tell you about the value of the resistance of this resistor that it is with? A very bright bulb would show you that that resistor is what? Low or high resistance. And then a higher current strength, what does that show you? In the circuit, you can see we've got the battery, we've got the bulb, and there we've got the wire, which is a resistor. And this wire is what we're interested in. This resistor is what we're interested in. And there completing the circuit is an ammeter. Now, if we find that the ammeter reading is high, what would we deduce about the resistance of this resistor? Would that tell us that it's a very resistant wire or a not so resistant wire? In case you don't really know how to answer these questions, let's speak a bit more about what resistance means and how we can think about it. Remember that resistance means how difficult it is for electric current to flow. So let's now think about water pipes. So here we have water filling these pipes. Which of these pipes is more difficult? You can see that in each of these two cases, we have two thick pipes on either side of a narrow pipe. But on the right, the pipe is more narrow. It's thinner than on the left. So which one of these do you think is more difficult for the water to flow through? The thicker pipe is easier. The thinner pipe is more difficult. So now, remember that resistance is how difficult it is for the electric current to flow. In the case of water, it's how difficult the pipe is for the water to flow through it. So this one's more difficult than that one. So now, how does the resistance of each of these pipes compare? Which one has a higher resistance? Which one has a lower resistance? The easier pipe has a lower resistance. The more difficult pipe has a higher resistance. So for which of these two would the water flow the fastest? The water would flow fastest where there's less resistance, through the thicker pipe. the water would flow slower where there's more resistance, in other words, through the thinner pipe. Just as the current strength through an electric circuit will be greater when there's less resistance, the current strength through an electric circuit will be less when there's more resistance. This is, of course, as long as the voltage is the same between the two. Just as this is true only if the pressure applied by the pumps is the same in both cases. So let's get back to this question. Now I've changed it a little bit to make it a bit easier to answer. A brighter bulb indicates that the wire or resistor is easy or difficult. A higher current strength indicates that the wire or resistor is easy or more difficult. I hope you saw that in both cases that means it's an easier wire to go through. That's why the bulb is brighter, because it's so easy for the current to flow so fast. And when the current flows so fast, the bulb is brighter. So now, how about the resistance? Brighter bulb tells us the resistance of the circuit is less. A higher current strength tells us that the resistance of the circuit is less.